With the early history of intelligence tests out of the way for the most part, we can talk a little bit more about what kinds of tests we might see today in a more modern setting. That doesn't necessarily mean that they are all very updated and modern and shiny and new. A lot of them actually come from the same original tests that we've already discussed. For example, if you've taken an intelligence test, say gone online, and sort of searched up a free IQ test, they usually print out a single IQ score and are probably the Stanford Binet test or some variation upon that test. It was actually originally revised for the first time by Louis Terman, who went back to Binet's tests and sort of changed them up, standardized them a little bit, made a bunch of adjustments, and that was really important for use during World War I, where they were trying to find a way to screen new recruits. So they wanted to have these intelligence tests to have a cutoff for people to be able to enter into the army. And so if you scored above a certain value, then you would be approved. And they had a couple of different variations here because they wanted to make sure that they could get in as many people as they could. And so they didn't want to have to exclude people if they, say, couldn't read or write. So they had a verbal version and a non-verbal version, but it had the standard asking those questions with the intention of seeing how somebody would be likely to perform as part of the army. Another really common one is going to be some sort of subset of the tests designed by David Wechsler. And these Wechsler scales are a bunch of verbal and non-verbal tests. And they go for, or they try and get at, a bunch of different sub-tests and sub-skills within those. This one has a little bit of sort of performance tasks. And as we can see on the screen here, there's a whole bunch of different variations to it. So they have the Wechsler Adult Intelligence Scale, the WACE, and then the Wechsler Intelligence Scale for Children, the WASC. Those are the two that you're going to see most often. And then they're designed for either children or adults, as the name would imply. This one is the most widely used of the intelligence tests nowadays, at least when it comes to more professional settings. You have a lot of availability of Stanford Binet type tests through the internet and things like that. But these are the most commonly used by, say, psychologists and others who want data on intelligence. And as per usual, it's a lot of asking people to answer questions, solve problems, find patterns, apply some of their fluid reasoning and other types of intelligence, which we'll end up talking more about those different types of intelligence in just a bit here. Now, with all of that said, with all of our discussions about finding a way to quantify intelligence, what can we do with those intelligence scores? What does it tell us about individuals? And so, of course, people have tried to find things that correlate with intelligence. So if you are highly intelligent based on one of these tests, what else do you also tend to be very good at or very bad at? And we have to take a step back here and make that comment that these are correlation studies, so we're going to keep that in mind as we interpret our results here. But we see that intelligence test scores correlate with academic performance. That shouldn't be too surprising. So highly intelligent people might do better in school. All right, we can understand that. We also see that highly intelligent people also tend to have sort of higher occupational status and higher job performance. So they tend to have more advanced positions within their companies. They also have higher income on average. And when we look at sort of their life scores, their like patterns across their entire lives, they actually tend to live longer and healthier lives than those with lower intelligence. So kind of interesting to look at this. And so you'd say, well, obviously it's very, very good to be highly intelligent then, of course. However, that thing about keeping in mind that these are correlations, we need to look at them and say, okay, but what else could be going on here? So we could even go with simply saying that good academic performance and then getting good grades and possibly continuing on with an education might set you up for a higher paying career in the future. So that would explain the occupational status component and the income component. And maybe there are some school skills you'd learn that help with job performance. And then having a higher income would then allow you to be healthier and live longer because you'd have access to regular medical care. So those are absolutely things that tend to occur. We would also want to keep in mind that even academic performance itself might be influenced by something and tied up with the intelligence component as well. So what if we think about people who live in, say, higher socioeconomic status areas or lower socioeconomic status areas? In those higher status areas, you would see more funding. You'd probably see better schools, more teachers, and fewer students in a classroom. And that kind of environment would then be conducive to learning. We're also going to find that a lot of the conventional intelligence tests also have a bias to match some of the reasoning and logic skills that are usually very strongly stressed within the schooling environments of the countries that they're designed for. It's one of the reasons why, if we look at, say, an intelligence test designed for Canada versus the US, even if they are very, very similar and like they're both in North America, but Americans will perform better on the American test than the Canadian test, and vice versa for Canadians. So we typically see that something about having a test structured for that country and the way that that country tends to sort of teach rational thought, that could be involved there as well. So there's a whole bunch of other stuff that could be going on in the background. And like we'll find as we go through this course this semester, there's a lot of things that end up being able to be tied back to socioeconomic status. And especially if we look at it as, wealthy parents are probably going to be fairly well established and have, say, access to money that could get you into a university or help pay for an education. You have more enriched environments, a lot less stressors that might come from being in a lower socioeconomic status. And those effects can then sort of carry throughout your life. So children are a lot more likely to be of similar economic status as their parents. So yeah, definitely things to keep in mind in the background. Once again, because you could look at these correlations and you could come to that very simple conclusion of intelligence. Highly intelligent people will earn more because of their intelligence, but they are correlational studies and there are always other things going on in the background. Oh, and just in case we wanted some visuals here, so this is their one of the studies where they were looking at income and IQ, but they did something neat here where they actually looked within families, so siblings, and what the IQ of these siblings were versus their earning at their job. And then this would account for things like the parents' wealth. This would account for things like maybe school environment and stuff like that. So we see that the higher the IQ, the higher the earnings, and lower the IQ, the lower the earnings. But again, we could probably come up with some things to be considerate of in the background. We'd also maybe be a little bit concerned that there's no error bars, so we're not sure how significant this difference might be. As per usual, we keep stuff in the background just in case. Oh, and another one. So this was another study. And once again, it's a little bit more observable here that this would be a correlational study. But here, each dot is going to represent a country, and we see a positive correlation that says that smarter countries tend to also have happier citizens. So here you're saying that happiness correlates with intelligence. So you could erroneously conclude that being smarter makes you happier. But again, we would want to keep in mind some of the other possible explanations that could go on here. Yeah, and I don't want to, I've already gone into the details on it, so we're good there. So our next little section here is getting into some of our different theories on the potential nature of intelligence. And this is, once again, a very widely studied topic, and there's a whole bunch of different theories on how people think that we should be breaking down intelligence. And we've been looking at things like, say, our Stanford Binet test, where we only get one IQ score, and it's just intelligence is this one thing. We then have other models where they'll break it down into lots and lots of individual components. But one of the big ones that we're going to talk about here is this two-factor theory of intelligence. And so this thing at the bottom here, this is actually where this theory ends up. So we're keeping this in mind as sort of where we're going to go once we've added to it and thought all the way through this. But when we start off, we're working with Charles Spearman, who thought that there should be some kind of hierarchy to different intellectual abilities. Specifically, he was really set up with this idea that we have some kind of general intelligence, sort of overall intellect and mental ability that would end up influencing sort of all aspects of our sort of intelligence. And then underneath that, we would have a bunch of different sub-abilities, skills that would be more specific to our tasks. And so in this situation, we'd be starting with that general intelligence at the top, and then he was really focused on what we see here at the bottom. So when he started, this middle row didn't exist. But he was saying, okay, so general intelligence. So if you are high in general intelligence, then you would be good at a whole bunch of different skills. But that can also then be modified or modulated based on the type of skills that you are good and bad at. So let's use the example of classes and subjects within school and things like that. So a person with high general intelligence would probably get fairly high grades across all classes. They might be better or worse in certain specific subjects. So maybe they're really good at math, but really terrible at English. So we would say that for their specific skills down here, we'd say that, well, maybe they're good at logic and numerosity, anything to do with numbers, but maybe they're really bad at verbal skills. They're not very fluent in speaking, or maybe their comprehension of text is not great. So we'd have those specific skills at the bottom here, and those would affect the overall observations, but all fall under our general intelligence. As we saw in the image, though, we actually end up getting to more of a 3-level hierarchy instead of our 2 levels that we talked about before. So we still have general intelligence at the top and still have specific abilities at the bottom, but in the middle, we'd have middle level abilities or group factors, depending on which model it is that we're looking at. And so they break this down, once again, into having sort of that overarching skill or ability, then some more general skills and abilities. And then underneath each of those, we could then divide it up into much more focused and specific skills at the bottom. So how did we get that middle addition there? How do we decide that that's what's going on? One of the main not factors, I'm reading factors. One of the main techniques that they use is called factor analysis. Now, factor analysis is kind of a weird and complicated technique. And it's not exclusive to just intelligence tests. This is a really common thing to use in psychometrics. And it's actually a statistical technique. So it doesn't have to be associated with psychology at all. You can use factor analysis as part of your statistics. And in fact, I have used something very similar to this concept with my own research to take large data sets and sort of condense them down into more useful forms. So let's talk about what this factor analysis does. And once again, in very simplistic terms, not anywhere near the statistical rationale behind it or anything like that. We're just focusing on the fact that with factor analysis, we get to reduce a large number of measures to a smaller number of clusters or factors that are all going to be related to one another. And specifically, those clusters are then not related to other clusters. So you can look at this and say, okay, well, an intelligence test would have a whole bunch of different types of questions, and they might get at a whole bunch of different skills that you might be capable of. So maybe we're going to look at ability to speak fluently, but also ability to respond correctly to questions that are posed, but also our ability to write very sort of intelligently or something like that. And all of those skills, they might end up overlapping using some of the same underlying abilities. So something about language proficiency might definitely fall under that category. So when we have these intelligence tests and these massive numbers of types of questions, we have a lot of measures to work from. And not all of them are independent of one another. So we run our analysis to see if we can collapse those down. And each factor would then be all of the parallels, all of the similar things that touch on or that come from each of those measures. So we would say that each cluster, each factor would contain variables, the measures, that correlate highly with one another, but they're going to correlate less highly with other variables in other clusters. The goal here is that each cluster would be closely related, all coming from the same underlying skill, but that cluster would be independent using a completely different skill than what we'd see from another cluster. So this allows us to make some assumptions to infer that there might be this underlying characteristic or skill that presumably accounts for all of the links between all of our different variables in that cluster. And if that didn't quite sink in for you because it's kind of abstract, I have a visual for it. So here we would have, in this situation, we have six different variables or six different measures that we've got from one of our tests. And so this table is actually a list of correlation coefficients. And so this number here is just saying that one correlates with one perfectly. Makes sense. This is why we have all of these 1.0s, because if you compare a value to itself, it's always the same. So we ignore that column. And then here we'd say, okay, 1 and 2 have a correlation coefficient of 0.84. It's a really high correlation. 1 also correlates very strongly with 3. And then here we see that 2 and 3 correlate strongly with each other. So 1, 2, and 3 all have these high correlation coefficients with one another. That tells us that they belong in the same cluster. We can then look over here and see that 1 doesn't really correlate strongly with anything else. Similarly, 2 doesn't correlate super strongly with anything else. 3 doesn't, and so on. So that tells us that these 3 values, 1, 2, and 3, are part of the same factor, and that means they're probably describing the same ability. So with my 3 different measures of, say, language abilities, that might be what this one is. We also see down here that 4, 5, and 6 have a similar cluster, where they cluster strongly and correlate strongly with one another, but don't correlate very much with the other variables. So in this situation, that might be, instead of language ability like the oranges, this might be something like mathematical ability. And so they are separate factors, and specifically from how everything runs in the background, when we hand wave the statistics component, these 2 factors end up being independent of one another. And you can kind of think of this as, with our output, each factor gets its own printout that tells us, okay, here's how we would use these 3 different variables to describe the pattern that we see here. So we can have these 3 measures and we can collapse them down using an equation. So now, instead of having to do all 3 of them, having to look at all 3 separately, we can look at them as a combination into one factor. And so the idea here is just that we want these factors to tell us what we think skills might be. So each of these is a theoretical underlying characteristic or skill, and then each factor would be put in here as one of our mid-level skills. So our general intelligence is the overall relationship between all of these mid-level skills. And then the specific clustered or factors would tell us how many of these there are, and we could probably figure out which ones they are too. So that's interesting, at least for me it is. But we also had some sort of caveats and some hiccups in this process. So another individual here, Thurstone, looked at the results from Spearman and said, actually, because you're saying that, or because when we run our factor analyses, we see this clustering, we see these independent factors, we could say that there is no need to talk about that G factor as some overarching factor. All we would need would be our clusters. Each cluster would be its own ability, its own skill, and everything else is unnecessary. So he thought that Spearman was overcomplicating everything and said, nope, we just need all of these individual clusters, and each of those would then be our specific abilities. So very few stable and specifically independent primary mental abilities that are all going to do separate things, and that there's no need specifically for that G factor, that overarching idea of general intelligence abilities. And what do we get from that? We have 7 primary mental abilities proposed by Thurstone, and he said that these would be those replacements for Spearman's idea. So we have space, our ability to look at visual scenes, maybe identify things in pictures, maybe to locate hidden objects, something like that. We get our verbal comprehension, so can you listen to and understand spoken components? Word fluency, which I seem to be struggling with today, that ability to produce verbal statements. Number facility, dealing with numbers. Perceptual speed is looking at how quickly we can recognize visual patterns. Rote memorization, which is what it sounds like. And then reasoning, logic, rationalization, that would be one as well. And a lot of these concepts are going to be very similar to ideas that we carry forward into a bunch of our other theories, but this is sort of one of the earliest proposals for these specific primary mental abilities. And so we now have these 2 competing theories, except instead of the standard where we have sort of these 2 opposing fields and people would subscribe to one or the other, what we actually ended up seeing was a collaboration, sort of sticking them both together. So both of these researchers ended up being kind of right in their own ways. And so there's been a whole bunch of different follow-ups. They do lots of those mathematical techniques and statistics in the background that showed not only those individual factors, those individual clusters, but also the effect of an overarching component that would be called our general intelligence. And so that's where we end up with something like this, with effectively Thurstone's specific or primary abilities in here in the middle, and still having general intelligence and the more specific abilities that fall under each of those primary abilities, putting us into this 3-level hierarchy once again. So this is kind of neat that we got to see the 2 of them come together. And we'll see a more evolved version of that in just a minute. Now, that is one way that we can get those techniques, or not techniques, we can get those clusters and factors, one way that we could identify each of those abilities or skills. And what we've described so far would be a data-based approach. So this is when we've taken all of our intelligence test scores and we've run our statistics and we've found mathematically, here's how these things cluster. Here are a whole bunch of factors that are independent of one another. What we would do then is look at which of the different measures end up in each of those clusters, and then we'd say, they seem to all be related to this type of ability. That's what we're going to call that factor. That's what we're going to call that skill. So we could come over here and look at our correlations, where here we have our two blue skills, and they correlate very strongly with one another, but they do not correlate almost at all with these orange skills. And looking at them, we get some kind of physical ability here, and over here we have more of a some verbal, some number work. So that would be more maybe school-like abilities, academic type abilities. So that's one way, but not everybody loves that approach. Not everybody wants to run factor analyses. They might think that they have better descriptions. So that's where we get our, apologize for the noise if that bled through. But yeah, our next option being a theory-based approach. And this says, instead of starting with the data and running our statistics to get clusters and then assigning a name to whatever makes sense for what's in each of those clusters, here you start with a whole bunch of abilities. So can you describe a bunch of abilities that you think should relate to different aspects of intelligence? So instead of what we saw before, where we had our data and then we said, aha, these look like physical abilities and academic abilities, let's think about some things. So physical coordination and academic skill might be two things you think are central to intelligence. If we look at some existing intelligence tests, or if we think of questions that could help us get at those aspects of intelligence, we could totally put together a way to study these. So for some people, this is a much more logical progression, where you start with the ideas and then check in with the data once you've already determined that this is probably something that should exist. You can then make adjustments once you've checked that data, once you've checked existing scores or designed your own. But we start with the concept and then go back to the data, where here you start with the data and then make the concept that fits within that data. One of the biggest benefits of the data starting, or the data-based approach here, is that in this case, these are all independent factors, meaning there's no overlap between those skills within each cluster. However, our data-based approach, there is that potential for overlap. So we might have that if you had academic skill in one, but then you also went and did like comprehension of something else, something written, and that wasn't put here. Maybe it was put in more with language abilities instead of specific academic skills. Those two might have a lot of very similar underlying processes that wouldn't have been separated out. So it's kind of about what the researchers want to prioritize, independence or not, and you get a little bit of both. So our example from earlier with those sort of three-level hierarchies, that would have been data-based, at least for most of it. We started with the idea of general intelligence, but all of the sort of sub-levels ended up being from factor analysis, therefore data-based. We have sort of additions to this, or very similar examples here, follow-up theories that look effectively the exact same. And these were mainly just building off of what was originally proposed with Spearman and then modified by Thurstone. This one here was actually designed by John Carroll, who found 8 different independent mid-level abilities that he wanted to put in place instead of Thurstone's primary mental abilities. And you're going to find that they are very similar here. He just wanted to break things down a little bit differently. And in this situation, we'd be looking at our general intelligence, or G factor, or just G at the top. And then they called it broad and narrow instead of medium and specific, but it's the same basic concept with a tweak. And so here, after running a whole bunch of different numbers, starting with actually like 400 plus data sets, they ended up coming up with this idea of these 8 individual sections, these individual ideas, abilities, being the ones that are important. And so 2 of these we should already be kind of familiar with. The idea of fluid intelligence and crystallized intelligence. So as a refresher, fluid intelligence being that ability to think flexibly, so apply solutions in novel ways, come up with new solutions to problems maybe that you've never seen before, creativity and thinking. Whereas crystallized intelligence would be a lot more of using your experience, using solutions that have worked in the past, things like that. And fluid intelligence tends to be very high when we're young and tends to drop off as we get older. So as our brains start to change, we can't think as quickly, as fluidly, and so we have to rely more on crystallized intelligence. But conveniently, as we get older, we also have more experiences, and therefore crystallized intelligence increases. It's one of those reasons why we don't see as large of a drop-off in intelligence as we get older as you might predict otherwise. They also described general memory and learning. So this would be that ability to store and retrieve information, visual perception abilities, auditory perception abilities. My mistake here. I was looking, so with the general memory and learning, that's more about the storage. Retrieval is retrieval. I lumped them together in my mind because I usually talk about both together. But yeah, those were separated out for whatever reason. Then more cognitive speediness, that rate of perception that we talked about before would be similar. We also have processing speed. So this one would be more of how quickly you can think. And this one would be a lot more about how do you react to things, or how quickly can you react to things. Again, there's a lot of specifics in the specific models about what would and wouldn't fall into each of these categories. We don't really need much more of that. The vague overall components here are sufficient, and especially we're going to talk mostly about fluid and crystallized intelligence. The others are a lot less important. Mainly just the fact that they keep coming up regularly in slightly different ways in a bunch of these different models. And so they'll call it something a little bit different each time. But it's neat to see the parallels between this model and our original one that we discussed, because they are pretty much identical except for how they choose to break intelligence up. And of course, I hadn't looked ahead, and I have an entire slide just for that crystallized versus fluid intelligence that I already did on the previous slide. But this allows you to see what I said verbally, just written down here. So crystallized, taking existing knowledge, applying it in our current situation. Fluid is we're dealing with novel situations with no previous knowledge, and we're able to sort of think up creative solutions in those situations. So usually we'll see things like relationships, sometimes very abstract connections between different concepts that we might be able to reason our way to a logical conclusion, and make some inferences to find those creative, flexible solutions. All right, so our next slide here, this is kind of a combination slide. So this is an example of one of the questions from an intelligence test called Raven's Progressive Matrices. So you might sometimes just see it called Raven's Matrices. But this is a nonverbal test, so showing visual patterns, and it's used for trying to quantify general intelligence as well as abstract reasoning. One of the reasons why this is so important is because by just getting into shapes and patterns where there doesn't have to be that verbal component, all of a sudden we're not limited to where this test can be conducted. We don't have to translate it between different languages. And because this is just pattern recognition and just visual pattern recognition, enables us to look at different measures of intelligence in different countries without as much bias as we would see from our verbal components or even written intelligence tests. So, as you might probably guess, just from the description of what kinds of skills people are using to answer these questions, this is definitely a great estimate of fluid intelligence, that ability to find patterns and solve these problems without having existing exposures influencing your ability to find those patterns, because each of the questions is going to be different patterns, different solutions, so you have to be flexible. And the other reason why we really like this, leaning more into that, you can give this in multiple countries, and the lack of a verbal component, the lack of a written component, is going to help us avoid some of the bias that comes from tasks that match the education systems of the countries it's designed for. This gives us a more level playing field when comparing the scores of intelligence across multiple countries. And a little bit later on, I think towards the end of the chapter, we have a discussion about differences in intelligence, where we found patterns of differences between the sexes, difference between countries, all sorts of things like that. And as we implied earlier on with some of our origins of intelligence tests, a lot of them had very racist approaches and were built on these theories of some people being better than others. And a lot of that ended up being backed up by tests where they found that people in other countries were scoring far lower than the countries where the researchers were. And that led them to the conclusion that our country is superior. And especially when they get in that genetic component of intelligence, it wasn't just superior, say, education, but superior genetics, because that influenced their intelligence. Of course, we would now look at it and say, but it's only because, or mainly because, you have this bias in the types of questions and how it's delivered in these different places. And as soon as we level that playing field, we don't see as large of differences. There are still some patterns that can be observed, because we're never going to find a completely unbiased test. But a lot of those massive differences that were originally touted for sort of proving certain groups being better than others definitely didn't hold up to any kind of rigorous testing after the fact. So we'll talk a lot more about that later on, but this is one of those tests that kind of changed the game when it was proposed. So it's a really interesting one and very good to talk about. All right, so those are all of our data-based approaches that we're touching on. We also went on a couple of tangents, but also we want to talk now about some theory-based approaches, just as examples to show that both of them are used. Sternberg proposed the triarchic theory of intelligence that, you might guess from the title, contains 3 different components that he thought were core to human intellectual ability. And so in this case, we'd say, all right, so analytic intelligence, creative or synthetic intelligence, and practical intelligence are the 3 components he's interested in. Because this is a theory-based approach, he starts with those ideas and then sort of checks that against data, against different existing studies and new stuff he designed himself. But in this case, he started with the ideas first. And so these aren't independent of one another. They are slightly separate, but definitely still have some overlap between them. So analytic intelligence was focusing on your ability to problem solve. This is what our traditional intelligence tests would be measuring. The others are getting a little bit more creative in what they're getting at. So creative or synthetic intelligence would be our ability to generate novel solutions using existing skills and information in a new way. So kind of familiar, kind of similar to some of the ideas we've already talked about. And then our last one, practical intelligence, that's the ability to adapt to everyday settings in the real world in a practical way. And so that kind of makes us think a little bit back all the way to that discussion of practical wisdom versus more theoretical wisdom back with our Greek philosophers, or nowadays book smarts versus street smarts. But yeah, a lot of echoes of some of the other theories we've talked about. I also include for this discussion possibly my favorite awful figure from textbooks, I have been collecting the worst ones and just keeping them together. So this isn't something you need to know. It's awful and thought I needed to share. But here we have our three different types of intellectual competence or mental abilities up here, the analytical, practical, creative. And then down here, he's saying that there are three specific components that contribute to each of those. And they all affect all of the different types of intellectual competence, which is why I don't understand why you need to have arrows in separate boxes for all of them. But I digress. But here we have some meta components. So this is how we're going to start planning and regulating our task behavior. You can kind of think of this like your control center. This would be your central executive if you go back to some of our memory models, if you've taken 104. But here we make a plan. We are going to decide on different courses of action. Once we've decided on our plan, these performance components help us execute strategies. So we've set out the task, here's what needs to happen, make it happen. And then we have our knowledge acquisition components, and this is how we're going to encode and store information. So as we're working through our steps, we're going to be learning things, what works, what doesn't, what else have we uncovered, what have we already tried. So storing that and then possibly using it later on in our progress or process. So that information is useful, the graph itself is not. And I suppose here, for this overall theory, each of these, you could be high in all of them, you could be high in none of them, you could be high in analytic, but not in the other two. But as we said, there would be some overlap, potentially, in the different sort of mechanisms, the different things going on behind the scenes that might influence multiple of these all at once. So it's more meant to be a descriptor rather than us trying to break it down into specific components or mechanisms that would lie under the surface. And you've probably picked up on the fact that when I'm talking about things and we're just saying we want to understand how this works, we typically talk about sort of underlying mechanisms. So what is the mechanism, the way that this thing happens to occur? It's a general catch-all term to just say that we want to know how it works, and that's how we're going to talk about it. Because some people might care about specific neural mechanisms, some might care about specific behind-the-scenes thought processes, but we're not getting into that level of detail. We just lump them together, call it that black box of underlying mechanisms. I didn't know if I had made that clear before. You've probably figured it out, but just in case you haven't, that's what it means. Our next of the theory-based approaches here is Gardner's theory of multiple intelligences. And here, once again, they're not necessarily specifically independent. They're called relatively independent. And he proposed 8 relatively independent intelligences, though there has been some discussion about adding a 9th possible type of intelligence, specifically existential intelligence, which is kind of an abstract concept here. But this existential component is tying to our philosophy that's all about our ability to think about meaning and existence and life and death. So people can muse about the meaning of life and think about maybe what comes next and be okay with their own mortality and things like that. And that would be high in existential intelligence. It's not necessarily always adopted in this situation. But for the 8 that people tend to agree on, these are them here. And once again, we're going to find a ton of overlap, where the linguistic component is on its own, logical and mathematical, that kind of sounds familiar, visuospatial, once again. Here we introduce musical, looking at our ability to perceive pitch and rhythm, which is kind of neat as an add-on. We also have body kinesthetic intelligence. So this would include more like coordination and ability to move in space. So people who are, say, dancers or athletes would fall under this category because they have really good awareness of their bodies and how they move and where they are in space. We could probably see some overlap with this kinesthetic component and our visuospatial component. less of the problem solving maybe, but same having that understanding of visual things, but also your ability to move through them. Then we have inter and intrapersonal intelligence, and that's looking at your ability to understand yourself or to understand others. In other models, we'll talk about that as emotional intelligence, which is coming up, but it's been divided up this way. And then the last component here is naturalistic intelligence. And this is sort of having this understanding of the real world, the natural world. So things like being a zoologist and understanding behavior from observing an environment, you'd be really good at this particular type of intelligence. And so once again, because this is that theory-based approach, we could see and could argue for a lot of overlap between a bunch of these different categories. But these are the ones that it was Gardner, that Gardner had originally proposed. These are the ones that he thinks most completely describe all of the facets of human intelligence. So just another possible theory that can be used. And as promised, I mentioned we would be coming back to chat about emotional intelligence, so it gets its own slide. And emotional intelligence is something that's gained a lot of traction in the recent few years. So this is focusing on our ability to reason about emotions and to use our emotions as part of our thought processes. So we would be able to read others' emotions accurately, but also respond to them appropriately. So that person is clearly sad. Here's something that might help, say, alleviate some of that sadness. If we go with that internal component, this might be to use your own emotions to motivate yourself and to be aware of your own emotions and internal states. And you can use that to then regulate and control your own responses. So emotionally intelligent people would be able to identify, describe, and manage their emotions and the emotions of others, and that might help them improve their decisions and improve their interactions with other people as well. This tends to correlate with, say, having better social skills, more friends, stronger relationships with others. And they tend to show a lot less neural activity in the parts of their brains that are related to emotions when they're solving these emotional problems than people who are emotionally unintelligent. Meaning that if you're high in this skill, it tends to take a lot less thought and processing to come to the right conclusions. So this is something that sort of comes easy to you because you're good at it. And that might be a pattern with some other types of intelligence, but I wasn't able to find, or I didn't have the time to look for other studies. I just know for sure about this emotional intelligence because it's very recently been brought into the public eye, and a lot of people are really curious about it. And so we also have, because if we're talking about emotional intelligence, there is, of course, a test to quantify our emotional intelligence. And this is MESKIT, MESKIT. Mayer, Salov, Caruso Emotional Intelligence Test. You will almost never hear the full thing spoken aloud. But here they have a whole bunch of different specific tasks that they want to use to measure each of those types of emotional intelligence. And they look at things like perceiving emotions say that the right way. We're going to quantify your ability to perceive emotions by looking at your accuracy in judging emotions, in facial expressions. So take pictures of faces and see how accurate people are at identifying which emotions they're seeing, but also to look at tones, how people talk, to see which emotions they're experiencing. And they're going to also get into things like, if we look at different visual things, how does this make you feel? How should it make you feel? Can you make that connection to, this empty, vacant landscape should make you feel isolated or make you feel sad or something like that? So obviously, when we get into something a little bit more abstract like that, there's definitely a little bit less precision So you'd have to be cautious in applying some of those findings, but it is a standardized test and it does give them a decent measure of how well people can read emotions. So this is one of the common ones. There are, I'm sure, many, many more of them by now, but this is just the one that I know.